When evaluating functions, we have to be really careful to be able to read this function notation clearly. So what you want to remember about functions is that when we say this notation here, this means f of x. This means the value of f when x is whatever you want x to be. F is not a variable. You don't substitute for x. You don't solve for x. It doesn't stand for anything. It's just a name. We could say because this one is f that this function is called Frank and this function is named George. It doesn't do anything to it. It's just a name. And this represents the output. It's the same thing as y, but we use this notation to be able to let the person reading know that this is a function without having to test it like we've done on previous problems. So when we want to evaluate, we want to pay attention to two things. We want to pay attention to which equation it's telling us to use, and we want to pay attention to what value of x we're supposed to be plugging in. So to do g of 5, we have to use the g of x equation. So we're going to do g of 5 equals, we're going to take out the x and replace it with 5. Remember, we have to do exponents first, so we have to do 5 squared, and then we can do our multiplication. So what we know is that g of 5 equals 75. And that's where you stop. I see a lot of people want to divide by 5 and solve for g. But again, g is not an unknown. G is just a name. This says when x is 5, George equals 75. That's all that means. So these next two examples are both asking us to use the equation f. So f of negative 2. F of x is 2 times x minus 1, so we're going to do 2 times negative 2 minus 1, which is negative 4 minus 1. So f of negative 2 equals negative 5. Last example, f of 4. We'll this time do 2 times 4 minus 1, which is 8 minus 1. So f of 4 equals 7. Again, what that represents is that our x value is 7, or 4, and our y value is 7. So that tells us an ordered pair that goes on that equation, 4, 7. Just a little bit more about what all that notation means. When we want to graph a function, we use a table to do the same thing. So if f of x is equal to x minus 4, that means to figure out each of these values, we are going to do f of whatever x is. So in this case, we're going to do f of negative 2, which would be negative 2 minus 4, so we get negative 6. For each one of these, we're going to do negative 1 minus 4, that's negative 5. 0 minus 4, that's negative 4. 1 minus 4 is negative 3. And 2 minus 4 is negative 2. What we get out of this is each one of these pairs in the table tells us an ordered pair. This represents negative 2, 6, negative 1, 5, 0, negative 4, and so on. So then we can graph those. Negative 2, negative 6 would be down here. Negative 1, negative 5, 0, negative 4, 1, negative 3, and then 2, negative 2. What we have to decide is should we connect these dots or leave them. We have to decide if it's discrete or continuous. Since we're just graphing this function which is linear, then we want to go ahead and connect the dots because we could pick any numbers that we want to put in that table. Those just happen to be the ones that we picked. So we should connect the line anytime you're graphing an equation.